Hello class, I was chasing for a dog in the first video, so we are going to make the video number 2 for my class and the assignment on the week 14 final block load calculations. We are going to continue with the question number 4, explain the purpose and recommendation regarding the filter. Here I can say the 3 main common restrictions are dirty filter and dirty evaporator coil and dirty condenser coil. The purpose of the filter placed at the return air area is to keep high cooling efficiency due to a good heat transfer between return and air, between return air and refrigerant. Also, system operate in acceptable conditions, prolonging the life of service. Also keep a healthy environment for the inhabitants in the building, trapping unwanted particles in the air that try to pass through the filter. So have a good filter, and clean filter is a good habit. Also, dirty filter will affect heat transfer efficiency, forcing the system to work hard to reach comfort conditions and the possibility to get frozen the evaporator coil. The next question is discuss different types of filters. We see that in our practice we have 2 different standards. The one we see in class was the MERV, that means minimum efficiency reporting values. The range is from 1 to 20. And the other standard is the FRP filter performance rating. That is standard for Home Depot filters. It's the one I use. Here the range they manage is from 1 to 10. As a comment, the more higher is the MERV rate, the more restriction you are going to have in your filter passing the air, with the possibility of low superheat differential and arrive liquid refrigerant to the compressor. That is not good. So what is the proper filter to use and what size? In my case, for my house, I use the filter that is a 20-inch by 25-inch size, and the rate is 5 FRP, filter performance rating from Home Depot. We use detailed load calculation in week 9 to calculate the size of filter based on the model number, and serial number. And we managed 3 constants. One was the 1 tonnage of power of the unit, generate 400 CFM, means cubic feet per minute. And the other constant was the velocity, that we managed 350 FPM, means feet per minute. And the equivalency to convert square inches to square feet, that we managed 144 to get the filter size. And applying the using the the model number, we need to use the model number of the nameplate of the condenser to generate to apply this method, to apply the formula and get your filter size. Next question is provide your recommendations. A medium rate My observations was the medium rate standard MERV filter is good to provide good service in the houses. This is the method that we use. It is the one that we calculate the filter size based on the model number of the unit. So I got very close results from the filter the IRA have with the filter the calculations give me. So it's a good method. So I recommend to check your filter size with this method and see if filter size calculated is close to your current filter size. Next question, number 5. How does the thermostat work and what does they do? About thermostats, I can say the thermostat use a set point as a reference to energize the split system components, depending if it is working in cooling, if it is working in heating, or it is working in fan mode. Now we are going to talk a little bit about these different modes. We are going to start with explain about cooling mode. In cooling mode, thermostat functioning is based on the temperature or reference as a set point. When thermostat sends indoor temperature above the temperature set point, it sends a 24 volts power to contactors outside, the compressor and condenser fan motor, and another 24 volts to the contactor and the indoor unit, the evaporator fan blower. Thermostat will open electrical circuit of these three components when thermostat sends the set point temperature was reached, and this process is named calling for cooling. Now let me explain a little bit about the heating mode. In heating mode, when the thermostat sends the indoor temperature is below the thermostat temperature set point, will energize the air handler sequencer, evaporator fan blower, and the heat elements to start warming the return air. When thermostat temperature set point is reached by the indoor temperature, thermostat will open and de-energize these three components. This process is named the calling for heating. Now the last mode is explained about fan mode. Here thermostat send 24 volts power to the evaporator, motor blower, and here there is not a set point, only is energizing the blower and moving the return air circulating in the building at the ambient temperature, but is no way to stop until externally someone can stop the process. That is the fan mode that can help when the system is frozen or something is not working properly. While the technicians come to fix the problem, you can use the system in fan mode just to circulate air. Thank you very much. I am going to continue with another video to complete my assignment, and I will see you in the next video. Thank you.